Hello mathematicians, welcome to my YouTube channel. Today we see one nice complex analysis problem. So many people are asking for complex analysis problem to me, so I thought of doing a complex analysis problem. So it is June 2014 part B question 38. So let f and g be two meromorphic functions on C. Okay, so what is a meromorphic function? A meromorphic function means a function C to C which is analytic except at finitely many points, and that points has to be poles. Okay, so there are various variants of definition of meromorphic functions, but we stick to this definition. Okay, so this is the definition given in Alfor's complex analysis as well as the complex analysis is Ponnuswamy sir book. Okay, so a meromorphic function is a function analytic everywhere except at finitely many poles. That is our definition. We take two such function f and g, and if f has a 0 of order k at the point z equal to a. Okay, so z equal to a is a 0 of order k for the function f, and 0 is a pole of order m for the function g. Okay, then we want to understand the function g of f of z. So if you look at the options, everything is given z equal to a. Okay, so we know the z equal to a is a 0 of f of order k, and z equal to 0 is a pole of order m for the function g. Then what can you say about z equal to a for the composition of these two functions g equal to f of z? That is a question. See, from here, if you look at my videos, I don't usually do the problems from just the problem solving perspective. I want you guys to understand the theory which goes behind it. Okay, so that any similar problems can also you can answer it. That is my main motto. So that is why my videos are a little bit long. For example, if for this question you can take f of z equal to z minus 1 whole square. Okay, then for this function 1 is a 0 of order 2. Okay, therefore a equal to 1 and k equal to 2 in this case. So so this is a equal to 1 and this k is 2, and we can take g of z equal to 1 by z square. Okay, then we get m equal to 2. This m is actually 2. Now we want to find the g of f of z. So what you need to do, you have to substitute f in the function g. So if you substitute this function in this function, okay, in place of z you have to substitute z minus 1. So what will you get? You will get g of f of z equal to 1 by z minus 1 whole power 4. Okay, now what is our a? As I said, a equal to 1. For this function, a is a pole of order 4. Sorry, 1 is a, I mean a equal to 1. So 1 is a pole of order 4 clearly. How do we got this 4? This 4 is a 2 times 2. Okay, therefore 4 is a 1 is a pole of order km. Okay, so from this one example itself, you can conclude that a pole of order m order km at z equal to a. That is the answer you can conclude. But I don't like this approach because I didn't even tell you what is a pole, what are these things. Maybe you know the definition of poles and zero, but so I would like to give you some my own perspective about poles and zeros also. Okay, and theoretically we'll see what is going on. So that way you understand something in theoretical also, which will help you in solving other problems. For example, these examples are going to help you solving only this problem. Okay, so we'll see my another approach, and we'll see how it is how I usually want to do things. Okay, okay, so again we take a function f from c to c. Here complex number alpha is said to be a 0 of order k if f can be written as f of z equal to z minus alpha whole power k and g of z, and for this g g of alpha is not equal to 0. Okay. If f of z can be written as g of z minus alpha whole power k and g of z where g of alpha is not equal to 0. If f can be written like this, then we say for f alpha is a 0 of order k. Okay. Now, similarly, we take a function f from C to C. A point alpha belongs to C is said to be a pole of order k. Or you take a singularity is said to be an isolated singularity. You take all, it is said to be a pole of order k of f if f should be able to return like this f of z equal to g of z by x minus alpha whole power k. Okay, if it is a 0 then z minus alpha whole power k comes in the numerator. If it is a whole z minus x, sorry, it is, this should be z minus alpha should comes in the denominator. Okay, and in, so if it is a pole of order k, then f of z can be written as g of z by g minus alpha whole power k, where this function g of z has to be analytic at the point a. This is a very important condition. Okay, here g of alpha not equal to 0. So this that this extra function we are getting, in case of 0 it satisfies the condition g of alpha not equal to 0. In case of pole, the numerator function we are getting, that should be analytic at the point A. Okay, these are two important things. We will see in the our argument that these two conditions play a crucial role. Okay, so I would like to point out one important example, like for the better understanding of what is a pole. For example, if we consider the function sin z by z, we tend to think that okay, z equal to 0. So this is z can be thought of as z minus 0. So it is written as, therefore we have z minus 0 in the denominator, therefore z equal to 0 is a pole because it is comes in the denominator. We tend to think like that. So that is a big mistake usually we do in the exams. Even if z comes, sometimes 0 may not be a pole. Okay, why? For this function 0 is not a pole of this function. Why? For example, so this is again some this is not a straightforward argument, but it is some justification. For example, you take sin z, the power series expansion of sin z around z equal to 0 you take. So sin z is an entire function. So this power series converges everywhere in the complex plane. So we can take this power series as a definition of the function sin z. Now what is sin z by z? If you look at this function, so basically one z coming out. That is an important thing, that was, since you can take out a z from here, that z will cancel this z. So basically there is no z in the denominator. So sin z by z equal to, so this is the power series expansion of this function, and so this power series converges everywhere in the complex plane. So, okay, so these things require some absolute convergence argument, but you can check in functional, sorry, complex analysis by Dr. S. Ponnusamy. Okay, so what we see is this 0 is a singularity for sure because that comes in the denominator, but actually it is a removable singularity. What is a removable singularity? This limits z tends limit z tends to 1, sin z by z equal to 1. So by defining a new function f of z as sin z by z for z not equal to 0 and 1 at z equal to 0, we can make this function sin z by z an entire function whose power series expansion is given by this. Okay, so the broader idea is z comes in the denominator doesn't mean that it is a pole. It is a removable single, it could be removable singularity. Okay, okay, so given this we go into the problem. So it is in the problem, it is given that f has a 0 of order k at z equal to a. That means f of z can be written as z minus a whole power k times some r of z, where this r of a not equal to 0. That is our definition of 0 of a function. G has a pole of order m at z equal to 0. Okay, then that means that g of z equal to some s of z by z minus 0 whole power m, where s of z is analytic at the point z equal to 0. That is our definition of pole. Okay, now we calculate what is g of f of z. So g of f of z means in the g of z, wherever there is a z, you have to substitute f of z in all those places. So in place of this z, I have substituted f of z here. In place of this z, I have substituted f of z here. So we get s of f of z by f of z whole power m. Again, f of z, we know the value, that is z minus a whole power k times r of z. I substituting this value, r z minus a whole power k times r of z whole power m. This m I have just to put it here. Okay, so we get s of so simplifying from this to this, if we simply we get s of f of z by this r of z. There is a typo. Oh, sorry. So r of z whole power m. This r of z whole power m, I am taking it with the numerator. So I get s of f of z by r of z whole power m. In the denominator, I get this k times m. I get km. Okay. So what we get? We get g of f of z equal to this expression. Okay. Now, if you look at it, this r of z comes in the denominator. But if r of z, if now we look at the point A, we know that r of A is not equal to 0, right? And r is an analytic function. Why r is an analytic function? F is an analytic function. Therefore, sorry, f is a meromorphic function. Sorry, f is analytic at A, because A is a 0 of f. Okay, 0 cannot be a singularity. Okay. So A is a 0 of the function f of z. Therefore, f is analytic at the point A. Therefore, by the if you look at this function, if f is analytic, you can conclude that this r of z is also analytic. Okay, that is a definition of 0, and r satisfies this extra condition. Therefore, this function f, this function s, this r, all these functions are analytic at A, and all of them are and r of a is not equal to 0. So if by the, you can actually quotient of tonality function is analytic if the function is well defined. Since we have r of a not equal to 0, this function is well defined at z equal to a. That makes the numerator function analytic at the point a. Okay, now we look at the definition of pole. So a is said to be a pole of order k if you need an analytic function which is analytic at the point A in the numerator, then whatever z minus a to the power comes here, that is the order. So for example, in this in our example, we get the power km. Km is what we are getting. Okay. Therefore, since this function is analytic at the point A, we get A is a pole of this function of order km. Okay. Therefore, we conclude that g of f of z has a pole of order km at the point z equal to a. Okay. Okay. So again, one thing to notice is, so by this detailed argument, we are reviewing what is a zero, what is the properties of, what is a pole, what are its properties. So this way we are learning the theory also. So I prefer to teach things in this way rather than just to pointing out to some particular examples like this and solve that is also fine. So if you learn this theoretical way, these examples will come to your mind automatically. I don't need to tell you. Okay, so that is the main difference. Okay, so I'm going, yeah. If you have some doubts, please comment below, and I'll meet you guys in some other different problem. Thank you.